So today our topic is switching. Guys, if you guys remember, in the first class, I asked you this question. What do you mean by switching? What do you mean by switching? Anyone? What do you mean by switching? Switching means just switch the packet. Switching means just switch the packet. Either you can say switch the packet or either you can say transfer the packet.
Transfer
Getting me?
the
Switching is the process of transferring data packet from one device to another
another
within
device.
a network or between a network. Right, everyone? I already written here either within a network or either between the network. For example, this is the PC, this is the PC, and this is the PC. There is one switch. So this is called within the network. Na? This is called LAN network because on every PC, you are going to assign the same network IP address. Right, everyone? Tell
Yes.
me.
Yes.
Yes, na? But if you have a router and if devices are connected like this, it means this is one LAN and this is different LAN. Yes or no? Yes. So
Yes.
here your packet will flow or here your communication will happen between the LAN, right? But in both scenario, what is happening? Switching of packet is happening. Transferring of packet is happening. Yes or no, everyone? I hope you guys understand, right now. So this is called switching. Clear, everyone? So switching is nothing. Switching means just transfer the packet from one device to another device, either within the network or either between the network by the help of various networking device. Clear, everyone? I hope you guys understand the definition of switching. Clear?
Yes,
Now,
sir.
how does switch work? If anyone asks you, this is the switch. How this switch works? Any idea? Guys, I already written here 5 or 6 or 7 points here. So let's discuss one by one. The switch receive a data frame one device connected to the one port. Let's suppose this is the PC. Let's suppose the IP address of PC is 10.1 and MAC address is 0A. Clear, everyone? PC is sending any packet. This packet will reach on switch. Let's suppose the name of this interface is fast Ethernet 0x0. It means this switch received the packet from PC number 1. Are you tell me yes or no? This is the packet. This
Okay.
PC is sending. Clear, everyone? Tell me.
Yes.
In step number 2, what I written, the frame are received, the switch learns the source MAC address and port it came from, it record this information in the MAC address table. If you guys remember, I told you switch maintain one table and the name of that table is MAC address table.
Mac table. Cam table.
So what switch will do, when this packet will reach on switch, switch check two things. First of all, switch will check what is the source address here, or you can say source MAC address in this packet. What is, guys? Source MAC address. Okay. And after that, switch will check, I am receiving this packet on which interface? Switch is receiving this packet on fast Ethernet 0x0. Getting my point, everyone? So in step number 2, switch will check two things. Switch open this packet and check the source MAC address. And second thing, switch will check on which interface I am receiving this packet and make a entry in which table? MAC address table. Are you clear, everyone? Yes or no? Yes.
Yes.
So switch
Yes.
will install on 0x0 on fast Ethernet 0x0. I am receiving this packet. And in this packet, what is the source MAC address, guys? 0A. What is the source MAC address? 0A. Clear, everyone? I hope you guys understand till now.
Yes.
See, over the time, if the switch does not see the frame from a particular MAC address for a while, it removes the MAC address from the table to keep the table current called aging. By default, aging time is 300 seconds. It means, guys, continuously this switch is receiving the packet from PC number 1. Okay. But let's suppose if in any case this switch will not receiving the packet on this interface. If switch is not receiving the packet from this PC, Getting my point? So in this case, this switch will wait how much time? 300. After 300 seconds, this switch will erase the entry from MAC address table. Getting my point, everyone? Are you tell me? Understand? So
Yes.
switch will take how much time, guys? 300 seconds. That is the by default time. And this is called which time, guys? Aging time. If anyone asks you what do you mean by aging time, you can say by default aging time is 300 seconds. It means if switch will not receive the same MAC address which is present in its MAC address table, then switch will wait for the 300 seconds, and after 300 seconds, switch will remove that entry from the MAC address table. Why? To keep the table current and updated. Getting my point, everyone? So that is the reason. So I hope you guys understand the point number 3 also. Clear, everyone? Are you tell me?
Yes.
Yeah. Yes, sir.
Now in point number 4, I write the switch read the header of the data frame to find out the destination MAC address. I hope you guys understand. I told you in OSI model, this is the PC number 1. PC number 1 is sending the packet. Okay, na? Whatever the packet PC number 1 is sending, either ARP packet or ICMP packet. For every packet, there will be a header. For every packet, there will be a header. Yes or no, everyone? Even you guys know about the Ethernet header also, right? I told you Ethernet header. In Ethernet header, there is a content, na, source MAC address and destination MAC address. Yes or no? I told you. In Ethernet header, there is a content, na, there is a field, source MAC address and destination MAC address. Yes or no, everyone? Yes. So what switch
Yes.
will do? Switch open the header and check the destination MAC address. And by the help of destination MAC address, this switch will identify the target device. What, guys? Target device. On the basis of which address? Destination MAC address. Getting my point, everyone? Now, switch receive the... Now, switch look up the destination MAC address in which table? MAC address table. Switch receive, let's suppose PC number 1 is sending the packet and source MAC address is 0A and destination MAC address is, let's suppose, 0B. Packet will receive on the switch. Switch check what is the destination MAC address? 0B. Now this switch will try to find 0B is present in my MAC address table or not. Getting my point? So remember these things. Switch will check the destination MAC address entry in which table? MAC address table. Clear, everyone? I hope you guys understand. Clear now? Now, the switch forward the packet, switch forward the data frame to the port where the destination device is connected. For example, let's suppose there are PC number 2 and this is fast Ethernet 0 by 1 and MAC address of PC number 2 is 0B, and on this, in this MAC address table, already 0 by 1 is on 0 by 1 MAC address is 0B, already entry is there. Let's suppose. So in this case, what switch will do? When this packet will reach on switch, switch check what is the destination MAC address? 0B. Now switch check 0B is present in my MAC address table or not. Switch will find yes, 0B is present in my MAC address table. By which interface? 0 by 1. And switch will forward this packet by 0 by 1. Getting my point, everyone? I hope you guys understand. Clear? And tell me. Okay. If the MAC address is not found in the MAC address table, then switch does not know where to send the packet. In this case, what switch will do? Broadcast. So let's suppose PC number 1 is sending. Source MAC address is 0A. Destination MAC address is 0B. Packet will reach on switch. Switch learn the source MAC address and make entry in the MAC address table. Now switch will check what is the destination MAC address. Destination MAC address is 0B. Now switch will try to find 0B is present in my MAC address table or not. Switch will find 0B is present. No, 0B is not present in my MAC address table. So in this case, switch do not know where to send the packet. So in this case, if the entry is not present in the MAC address table, switch will broadcast it. Are you getting my point? Everyone, tell me yes or no. Understand?
Yes. Getting.
There is one interview question. Can I ask? If you guys ready.
Yes.
Question is, tell me the scenario when switch will broadcast the packet. So guys, if anyone, any interviewer will ask you these type of question, tell me the scenario or condition when switch will broadcast the packet. The first answer you can tell, when switch will receive any broadcast packet, then switch will broadcast it. This is the basic scenario. And second one is, you can tell when switch will receive the packet and the destination MAC address entry is not present in its MAC address table. In this case also switch perform the broadcasting.
Broadcast.
Clear? Understand?
Yes.
Yes, sir.
This is the interview type question. Okay,
The broadcast, sir, broadcast address, this is EEE, yeah?
broadcast
Of the basic of MAC address, yeah?
means which will forward this packet through all the interface.
No, no, I mean the broadcast address. This is
Broadcast address is
EEE. F. Sorry, yeah.
okay. The next point is, guys, every time a switch receive a frame from a device whose MAC address already in the table, guys. See, when PC number 1 is sending the packet, right? Source MAC address, this switch already learned that this source MAC address, yes or no, everyone? Yes. But after some time, this PC number 1 continuously will send the packet. Yes or no, everyone? Tell me. Yes, na?
Yes.
Continuously PC number 1 will send the packet. But let's suppose for every time, switch do not learn the packet and make entry in MAC address table. Getting my point? What switch will do? By default, what is the aging time? 300 seconds. Yes or no? Yes, na? It means when if this switch do not receive the packet till 300 seconds, switch will remove this entry from the MAC address table. This is the meaning of aging time. Yes or no? Yes.
Yes.
So whenever switch will continuously receive the packet from the device, in this case, switch do not update the packet every time. What switch will do? Switch just adjust the, or you can say reset the aging time. That's all. Getting my point, everyone? Try to understand what I'm trying to say. Let's suppose this PC number 1 send the packet. Okay, let's suppose right now 10:29 and second is, let's suppose 15 second is happening. And this switch receive this packet at this time. Okay, let's suppose after 20 seconds, switch again receive the same packet. What switch will do? Let's suppose 10 at 15 second this switch receive. Okay, and after 20, it means 15 to 20. How many seconds left, guys? 5 seconds, na? Yes or no?
Yes.
Tell me, what is the difference? 5 seconds. It means aging time is by default 300 seconds. Now, what is the aging time? 295 seconds. Yes or no? Yes. And after 5
Yes.
seconds, when switch will receive, switch make the aging time again. How much? 300.
300.
Getting my point? So basically, switch will only reset the aging time, not
So
learning
if
everything.
okay, what if we change the destination port like slash 0/0/1 to 0/2, and MAC table is there already.
Sorry, if you change the port,
Yes, destination port.
see, I'm not understanding.
In,
See,
the,
na,
in this
actually,
case, destination, yeah,
only the source
this
MAC address, na.
and destination MAC address also it will learn after broadcast.
Switch,
0B it will
switch
learn.
learn, switch learn the source MAC address. Okay, so switch here learn the 0A. And if you were telling the destination device port you change, right?
Yes.
So if you
After
change the
already entry is there.
sorry, ARP entry is already there.
There
MAC
in the
address
MAC
table
address.
entry is already there. So when you change the change it, no, automatically switch will change the entry there also, na, destination entry. Clear?
Okay.
Switch will change the MAC entry in the MAC address table also. Clear, na? Basically,
Okay.
when you connect the port through the switch, at the same time, switch will learn the MAC address. There are multiple ways. There are by default, there are keep alive messages. There are CDP messages. Multiple messages are exchanging. Getting my point? Between switch and device.
And
Getting my point? By
Yes,
these
sir.
way, now switch already learn the MAC address. Okay. Now, guys, I mentioned this point because in some book you guys will get switch perform 3 tasks: listening, learning, and forwarding. In some book you guys will get 3 things: switch perform, listening, learning, and forwarding. Now the question is, what do you mean by it? The question is, what do you mean by it? Why we are telling switch perform 3 tasks: learning, listening, forwarding? See here. What do you mean by listening? Listening means, let's suppose whatever I am telling you, you guys are just listening, right? And after some time, what you guys are doing, whatever you listen, you capture all the thing in your mind, yes or no? Or you are just storing whatever I am telling the concept in your mind, yes or no, everyone? Yes, these are the things you
Yes.
guys are doing. And whenever anyone asks you, let's suppose any interviewer will ask you what you are doing, you are just delivering the thing what you store. Getting my point, everyone? Are you tell me? Yes, na?
Yes.
So this is the process you guys are also following. You guys are first of all listening, then you guys are uploading all the things which I am telling you in your mind, and when interviewer will ask you, you guys are just delivering the thing. So this is called listening, learning, and forwarding. Similarly, the same kind of thing switch will perform. Same kind of thing switch will perform. What switch will do? Switch, first of all, this is the switch. Switch continuously receive the packet on multiple ports. Yes or no? Everyone. Are tell me? Yes, na? And
Yes.
switch is receiving the multiple packet on multiple port. Definitely there will be a different MAC address. On this interface, there will be a different. On this interface, there will be a different. Yes or no? Everyone. Yes, na? So in this case, what
Yes.
switch is doing? Switch is just listening the
Listening.
different MAC address. Switch is just listening the different frame. Yes or no? Or you can say switch is right now just gathering the information.
Information.
Clear, everyone? Now this is called
Yes.
listening.
Listening.
After that, switch will perform the learning. Learning means switch store all the MAC address which switch received through the frame. In which table? MAC address table. In which table? MAC address table. And in MAC address table, switch make an entry like what, on which interface, on which port I am receiving the packet, on this interface, what is the source MAC address, like this. So it means switch make an entry in which table, guys? MAC address table. That is called learning. Are clear, everyone? Yes or no? Yes?
Yes.
As a switch listen to the traffic, it learn the MAC address of the device connected to its port. Yes, it learn the MAC address and corresponding to the port. Yes, on which port they are receiving the MAC address, which learn in its MAC address table. If the MAC address is already in the table, so in this case, what switch will do? Switch just reset the aging timer. Switch just reset the aging timer. Learning helps the switch to build and maintain a accurate MAC address table. Yes, basically learning is the thing. And when switch is learning the MAC address table continuously, it means by the help of learning, switch can make the MAC address table accurate. Yes or no, everyone? Yes, na?
Yes, sir.
Yes. So this is called learning. Now, next one is forwarding. Forwarding means Forwarding means whenever switch will receive the packet, switch check the MAC address table, and according to the entry which is present in the MAC address table, switch will take the forwarding decision, and that is called forwarding. Yes or no? Everyone tell me. Tell me yes or no.
Yes, sir.
Either switch will forward the unicastly, or either switch can forward the broadcastly. When switch will receive the broadcast packet, switch will broadcast it. If switch will receive the packet and if the destination device MAC address is not present in its MAC address table, in this case also switch will broadcast it.
Broadcast it.
And if already the entry is present in the MAC address table, then switch will unicast it. Getting my point, everyone? I hope you guys now understand there are three functions which perform, that is listening, learning, and forwarding. Nabil, understand?
Yes, sir. Yeah. Yes. Thank you.
Next thing is, what do you mean by MAC address table? MAC address table is what? MAC address table is nothing, that is a database. MAC address table is nothing, that is a database where switch make a entry of MAC address and that MAC address is connected with which port. Getting my point, everyone? Understand?
Yes.
What is MAC address table? MAC address table is just like a database where switch install or store the information about port number and MAC address. Now the thing is, what are the content you guys will get in the MAC address table? So guys, generally 3-4 content you guys will get. First one is MAC address. Second one is port number. It means that MAC address is connected with which port number. Third one is VLAN ID. VLAN ID. VLAN ID identifies the VLAN of the MAC address belongs to. It means the packets which receive on that interface, that packet belongs to which VLAN. Okay, now we will discuss VLAN later in a very detailed way. But yes, you guys will get VLAN ID also in the MAC address table. And the last one is, guys, type field. Type field means either switch receive the MAC address statically or either dynamically. Either switch receive the MAC address statically or dynamically. Guys, basically, if this is the MAC address table, so see, there are two ways by which switch learn the MAC address, either statically or either dynamically. Dynamically means when switch receive the any ARP table or any packet, switch learn the source MAC address and make an entry. That is called dynamic process. That is called dynamic process. But in some case, we are installing the MAC address statically. It means we are configuring on this port. This is the MAC address, that is statically. For example, let's suppose this is the switch and here one PC are connected and this PC is finance PC and this PC is very, very, very critical PCs for my company. So it means this PC is fixed on this interface. This PC is fixed on this interface. We are not going to change this PC from this port. Are you getting my
For
point? We are
security
not
reason.
Yes, we are not going to change here from this port to another port. We are not going to change. This is the very important PC. So in this case, what we will do, we will check what is the MAC address of this PC and we will map this MAC address with this port statically on the port. Getting my point? That is called static entry. Are you clear, everyone? Yes or no?
Yes, sir.
So basically there are two type of entry. Either you guys will get the static or either you guys will get the dynamic. Maximum scenario you guys will get the dynamic. See guys, I already inserted the figure here. This is the MAC address table. What is the command? So MAC address table. This is the command by which you can check the MAC address table of the switch. What is the command? So MAC address table. See na, VLAN, MAC address, type and port. So these are the content you guys will get. Clear, everyone? I hope you guys understand. Are you tell me
Yes,
yes
sir.
or no?
Yes, sir.
See now, I can show you if you want. Let's suppose I just open this switch. What is the command I told you? So, to MAC address. Here, everyone, tell me.
There is no traffic. Is there any device connected with the switch? Guys,
Is there any
No,
device
no,
connected with?
No.
no.
Now, what is MAC address aging time? I'm not going to tell you guys. I told you again and again multiple times. Aging is the process by which switch remove the old or inactive MAC address from its MAC address table. Right now, everyone, and by default time is 300 seconds. Clear? Everyone, tell me.
Yes, sir.
Yes or no?
Yes, yes, yes.
How it works? Every time switch see the MAC address, it reset the timer. Yes or no? Yes, na? If entry is already there in the MAC address table and switch is receiving the same MAC address table packet here, what switch will do? Switch just reset the aging timer. Are tell me yes or no? Yes, na? If MAC address
Yes.
table is it, agar if switch will not receive the any packet till 300 seconds, it means in this case what switch will do? Switch will remove that entry from that MAC address table. Clear, everyone?
Yes.
Tell me yes, na? And this is the process. By the help of this process, which is completely updated in the network. Yes or no, everyone? Yes, na?
Yes.
Yes.
I mentioned here, if you want, by default aging time is 300 seconds. If you want, you guys can change the time, but in real scenarios generally we are not changing this type of thing. But if you want, you guys have lots of if you guys want to do lots of things, yes, you guys can do. This is the command by which you can change the aging time. Are it clear, everyone? Yes or no?
Yes, sir.
Yes.
Okay. I don't think on packet tracer it will work or not. This is the command, guys. See, so MAC address table aging time 600. It is not taking. It means packet tracer is not supporting. Are you understand, everyone?
Yes.
MAC address table, it's not taking. I'm pressing the question mark. See, it means on packet tracer you can't do this one. Okay,
It's not
because
supported. No?
yes, on packet tracer there are multiple limitations. So that's the reason this command will not work on packet tracer. Even you can try on the GNS or EPNG, it will work. Clear, everyone?
Yes.
Now the next one is, guys, ARP. ARP means, what is the full form of ARP? Address resolution protocol. Again, I'm telling address resolution protocol. Guys, please think. Again, I'm telling address resolution protocol. Tell this word 3 times, everyone. Address
Address
resolution
Resolution protocol.
address resolution
Address
protocol.
resolution
Getting
protocol.
something in the name. It means ARP is nothing. It just resolved the address problem. Yes or no?
Yes.
Yes. Address resolution protocol. It means ARP is nothing. ARP is the type of protocol. When I think the ARP, I'm not going to define it here, and I'm not going to read the definition. Whatever I am reading and whatever I am listening, ARP means it just resolve the address problem. It is just resolve the address problem. So see, ARP means ARP full form is address resolution protocol. It is a protocol used for mapping the IP address to the physical address. It means this is the responsibility of ARP to map your IP address with the MAC address in your which network? LAN network. Everyone understand? Do you guys understand or not?
Yes.
Yes, sir.
See, ARP is the protocol, and that this ARP solve our problem. How? This ARP solve the problem like this ARP map my IP address with the MAC address in our LAN network. Don't forget this one. In our LAN network. Clear, everyone? For example, This is the switch. This is the PC number 1. This is the PC number 2. PC number 1 MAC address is 0A. IP address is 10.1. PC number 2 MAC address is 0B. IP address is 10.2. Let's suppose interface 0 by 0, interface 0 by 1. Switch maintain 1, which table, guys? MAC address. And this switch maintain like on 0 by 0, I am, which device is connected? PC1 is connected. And what is the MAC address of PC1? 0A. Right? On 0 by 1, what is the device connected? PC2 connected. And what is the MAC address of PC2? 0B. Are you getting my point, everyone? Yes or no? Understand?
Yes.
Now, this is about the switch. Now, come on the PC. Guys, please remember one thing. Please remember one thing. Switch PC also maintain one table. PC also maintain one table. What is the name of that table? ARP table.
ARP cache.
Which table, guys? ARP cache you can say, but ARP table PC also maintain what? ARP table. You guys know or not? Tell me.
Yes.
This is my
Yes.
CM.
About.
If I am writing, what is the command? ARP/A. See, these are the entry in my PC ARP table. Getting my point, everyone? Understand? Yes or no?
Yes.
Yes.
So it means PC
Yes.
also maintain the ARP table. Understand? And in this ARP table, what are the content? In ARP table, what are the content?
IP addresses with MAC address.
Yes.
Associated MAC address.
Everyone, this is the IP address and this is the. Are you getting my point, everyone? Yes or no? Tell me. Yes, na? So basically in the ARP table, what is the content? IP address map with the MAC address. IP map with the MAC. Yes or no? Everyone understand?
Yes.
On PC number 1, what is the IP address? 10.1. And what is the MAC address? 0A. On PC number 2, what is the IP address? 10.2. And what is the MAC address? 0B. Are you getting my point, everyone? Yes or no? Yes?
Yes.
Now, if PC wants to communicate with PC number 2. So if you guys remember in previous class, I told you, if you want to communicate from one device to another device, the 4 requirement, this is the must requirement. What? Source IP, destination IP, source MAC, and destination MAC. These are the most important requirement, right? Without this, we can't communicate. Are you telling me yes or no? Yes, na?
Yes.
Yes.
Okay. So if you write the command here, ping 10.2, it means this PC number 1 generate the packet. In this packet, what will be the content, guys? The 4 content. Source IP. What is the source IP? 10.1. Destination IP. You already written here, na? 10.2. Destination IP address is 10.2. What is the source MAC address? 0A. Source MAC address means PC MAC address. 0A. Now, what is the destination MAC address? Now, what PC will do? PC number 1 will check what is the destination IP address. What is the destination IP address? 10.2. Now, PC will try to find its ARP table. And in ARP table, this PC find for 10.2, is there any MAC address present? Then PC number 1 will find. And for 10.2, there is no MAC address. For 10.2, there is no MAC address in my ARP table. And if MAC address table is not, if MAC address is not present in the ARP table, then how PC number 1 will fill the destination MAC address? Is it possible? No, it is not possible. It means this packet is not completely encapsulated. And if your packet is not completely encapsulated, your device will never generate that packet. Getting my point? Everyone. First of all, your packet must be completely encapsulated, then after any device will forward it over the network, otherwise no. So in this case, this packet is not completely encapsulated. Why? The reason is this device don't know what is the destination device MAC address, PC number 2 MAC address. And here the concept of ARP. And who solved this problem, guys? ARP will solve this problem. I hope now you guys understand the advantage of ARP. Clear, everyone?
Yes.
Yes, sir.
So PC number 1. On PC number 1, you write the 10.0.0.2. So this PC number 1 will generate the which packet, guys? ARP packet. And this ARP packet is called the ARP request packet. There are two types of ARP, request and reply. So PC number 1 will generate the ARP request. Fine. This packet will reach on the switch and switch forward this packet towards PC number 2. And PC number 2 check the ARP table, learn the thing in and maintain the thing in the ARP table, and PC number 2 will generate the again ARP. And this is called what? ARP reply. So again, I am telling there are two type of ARP, ARP request and ARP reply. Are you clear, everyone? Yes or no? Yes? And one more thing you guys can remember, ARP request always be broadcast and ARP reply always be unicast. How I will tell you later. Okay. But remember these things, ARP request will be broadcast and ARP reply will be unicast. Are you clear, everyone?
Yes.
Why? The reason is, the main reason is, guys, I just want to tell you, the main reason is PC number 1 is sending the ARP request. And in this ARP request, PC number 1 don't know now what is the MAC address of PC number 2. Yes or no? Yes. It means destination MAC address is unknown for PC number 1. Yes or no, everyone? Are you tell me?
Yes.
Yes, na? So if destination MAC address is unknown, so that's the reason it is called broadcast. Clear, everyone? Can you tell me, guys?
Yes, sir.
Understand? So this ARP packet will reach on PC number 2. What PC number 2 will do? PC number 2 first of all check what is the destination IP address in this ARP request. Then PC number 2 will find what is the destination IP address in this ARP. 10.1. Sorry, not destination, guys. Source. What is the source IP address? Source IP address is 10.1. And now PC number 2 will check what is the source MAC address. Source MAC address is 0A. Then PC number 2 immediately make the entry in which table? ARP table. For 10 MAC address is 0A. And now PC number 2 will generate the ARP reply. And when PC number 2 will generate the ARP reply, PC number 2 know everything. Source IP, destination IP, source MAC, destination MAC. Yes or no, everyone? There is nothing unknown. PC number 2 know everything. So in this case, so that's the reason this packet ARP reply is unicast. Are you getting my point, everyone? This is very important interview question. Clear, everyone?
Yes, sir.
ARP request is broadcast and ARP reply is unicast. The reason is ARP request is broadcast because when PC number 1 is generating the packet, and for ARP request packet, the destination MAC address is unknown. So that's the reason it is broadcast. But when this packet will reach on PC number 2, PC number 2 open the ARP request packet which come from the PC number 1 and open the source IP address and source MAC address and make the entry in which table? It's ARP table. Getting my point, everyone? Now, after entering in the ARP table, PC number 2 try to encapsulate the ARP reply. And in ARP reply, PC number 2 have everything. Source IP, destination IP, source MAC, destination MAC. It means every data is present for PC number 2. So that's the reason PC number 2 will generate the unicast packet. Anyone who do not understand? I hope you guys understand very well. Clearly?
Yes, sir.
So this is called ARP request and this is called ARP reply. Clear? I hope you guys understand ARP request and reply. Understand? Are tell me.
Understood, sir.
ARP request is broadcast, ARP reply is unicast. Clear? A host send the ARP request to discover the MAC address. Yes or no? Yes, na? Which is associated with the specific IP address. Are tell me yes or no? Yes, na? And ARP
Yes, sir.
reply is ARP reply contain the MAC address which sender device is looking for. Yes or no? Everyone. That is
Yes.
ARP
Yes, sir.
reply. There is one more types of ARP, guys. That is gracious ARP. Gracious ARP is nothing. You can understand only one line. The main use of gracious ARP is to check the IP address conflict in the network. That's all. IP address conflict in the network means, for example, this is the switch and there are 4 PCs. PC 1, 2, 3 and 4. Here I configure 10.1, 10.2, 10.3 and 10.4. Getting my point, everyone? So when you configure the IP address, na, every device generates the gracious ARP. The reason is to check this IP address is unique or not. Getting my point? If the same IP address you configure on other device, you guys will getting the error because of the gracious ARP. Clear, everyone? Understand? The use of gracious ARP is to check the duplicacy of the IP address in your network. That's all. Are you getting my point, everyone? Yes or no? This is
Yes.
the packet. See na, hardware Ethernet 1, yeah, protocol is IPv4. Okay, hardware address is 6. Protocol type is this one. What is the important thing here? Important thing is this one. What you guys are getting? Source IP and destination IP both are same.
Same.
So now see now what is the interview question? Interview question, interviewer will ask you, tell me the any types of packet or scenario where source IP and destination IP address will be same. What will be your answer? Your answer will be sir, there is the gracious ARP. In case of gracious ARP, source IP and destination IP address is same, because if here if PC number 1 is generating, the source IP address is 10.1 and destination is 10.2, it means this device is checking this IP address is present in my complete network or not. That's all. Getting my point, everyone? So please remember this one. When what is the question? Question was, tell me the scenario or tell me the type of packet in which the source IP and destination IP address will be same. What will be the answer, guys? Gracious ARP. Clear, everyone? Understand? Second question interviewer can ask you, tell me gracious ARP is the unicast packet, multicast packet or broadcast packet? Gracious ARP is the broadcast packet. Gracious ARP is the broadcast packet. Why? Because what is the target MAC address? FFFFF. I'm audible to all of you.
Yes, sir.
Yes.
Yes.
I hope you guys understand. I already mentioned here everything, guys. If you guys have interest to read the thing, what are the meaning of hardware type, what is the meaning of protocol type, I already mentioned everything here. You guys can read it. Okay, I already written the in very easy language. Hardware type means specify the type of hardware. Generally, we are using the Ethernet. So for Ethernet, hardware type is 1. Okay, protocol type. Protocol means we are using the IPv4. We are using the IPv4. Yes or no? And for IPv4, type field is, guys, 0x0800. Please remember this one. Clear, everyone? Now, hardware type, hardware address length. Hardware address length. Hardware address means physical address. Physical address means MAC address. Yes or no? Yes, na? It means it is telling the MAC address length. MAC address length means MAC address size. What is the size of MAC address? 48 bit. If you convert in byte, how many byte? Are you tell me? Are 48 divided by 8. What is the value? 6 byte, na? Yes or no?
Yeah.
Yes, sir.
That's the reason. What is the hardware length? 6
Six
byte. protocol address length. Protocol address length means IPv4. IPv4. What is the size? 32 bit. When you divide, convert into the byte. What is the value? 4.
4.
That is the 4. Okay, everyone. I hope you guys understand. If you guys read it, you guys will understand. Right? Sender hardware address means this is the MAC address of the sender. Sender protocol address means this is the IP address of sender. Target hardware address means this is the destination device MAC address. Target protocol address means destination device IP address. Clear? Are tell me. I already told you everything.
Yes.
Everyone. Now, this is the header of, or you can say this is the packet of normal ARP, guys. This is the packet of normal ARP. See na? What is this? Address resolution protocol request. It means this is the ARP request. Arre, this is the ARP request. Getting my point, everyone? Yes or no? This is the ARP request.
Yes.
What is the hardware type? 1 for Ethernet. Protocol type is because of IPv4. What is the value? 0x0800. Hardware size is 6. 6 means guys, this is byte. Okay.
MAC address.
4 byte. Okay. Opcode. Opcode is 1. For request, opcode is 1. For reply, opcode is 2. Please remember. If anyone asks you, how can you identify this is the ARP request or this is the ARP reply? How? You can say by the help of opcode value. By the help of opcode value. If opcode value is 1, it means it is request. And if opcode value is 2, it means this is reply. Are you clear, everyone? Yes or no?
Yes.
Na?
Yes, got it.
Suppose PC number 1 is sending this ARP request. So see na, this is the sender MAC address. It means this is the PC number 1 MAC address. Clear? Sender IP address means this is the sender IP MAC address. It means PC number 1 IP address. Understand? Target IP address means you already written na here ping 10.0.0.22. It means this is the target MAC IP address. Getting my point, everyone, till now? Tell me.
Yes, got it.
Now one thing. What is the target MAC address here? 00000. But I think you guys have conflict, sir. Just 1 minute ago you told ARP packet is the broadcast, right? And for broadcast
Yes.
value is this one. And here when you are showing the packet, you are telling 000. I'm not understanding. What are you telling? I'm not understanding what you are telling. Tell me, I am asking on behalf of you guys. Why you guys are not
Yes,
asking?
I have a question, same question.
Okay.
I was about to ask.
Anyone have answer? No? Okay. See guys, first of all, one more thing, please remember, if anyone asks you, ARP is the protocol, you guys know, ARP works at which layer of OSI model? Some of you guys will tell, sir, at layer number 2.
L2.
Okay. But what I am telling you, please remember 2.5, not 2. What? 2.5,
5.
not 2. Clear? Everyone. ARP is the 2.5 layer, not 2. Are you getting my point, everyone? Yes or no? Because,
Yes.
see na, in ARP packet, we are getting the protocol type. Protocol type is telling above this, what is the address? So above this address is IPv4. Are you tell me yes or no? Above
Yes.
this, what is this? IPv4. And IPv4 works at which layer? Layer number 3. It means this one is using, or this one is working below the layer number 3. Yes or no? Everyone, tell me. Yes.
Yes, yes.
And this one is ARP. ARP is working after the Ethernet header. It means this is ARP packet is in the middle of Ethernet as well as middle of IPv4. So that's the reason I am telling you. Please remember the 2.5. Now come on the point. Point is target MAC is this one. Guys, PC number 1 generate the ARP and for ARP request. And for PC number 1 don't know what is the MAC address of PC number 2. So that's the reason PC number 1 in generating the ARP request. Yes or no? Yes, na?
Yes.
Everyone. Yes.
Yes. Mhm.
So that's the reason. See here, 0000 means unknown. 00 means what? Unknown. So that's the reason in ARP packet you guys are getting the target IP addresses 000. Why? Because PC number 1 don't know what is the MAC address of PC number 2 or destination device. So that's the reason address is unknown, or an unknown address is written like 0000 like this. Getting my point, everyone? Tell me yes or no. Yes? Tell me.
So 000 means also broadcast.
No. I am telling you, first of all, understand like this. This is unknown. Clear?
Yes.
Now, come on the broadcast. This is the 2.5 layer. It means below this, there are layer number 2 header, and that is called Ethernet header. Yes or no? Yes.
Yes.
In
Yeah.
Ethernet header, source MAC address will be this one. Okay? A. And destination MAC address, you guys will get the.
FFF.
This is the meaning.
Mhm.
Clear? Everyone?
Yes.
Oof. And switch will forward the packet on the basis of layer 2 header, not 2.5. It means your switch will not open the ARP. Your switch will open the Ethernet header. So that's the reason I told you ARP packet is broadcast. Clear? Because ARP packet is encapsulated with the broadcast address FFF at layer number 2. Clear? Everyone?
Sir, yes, sir, I have a question.
Yes, please.
Does switch have ARP cache or ARP table?
No,
I'm talking
switch
about switch.
Please remember one thing you told, then that's the reason I am telling you. Only two devices creating the ARP table, guys. PC and router. Switch do not maintain the ARP table. Switch only maintain the MAC address table. Okay, next.
Okay, thank you.
Clear?
Yes. Sir.
Yes, sir,
And
thanks.
one more thing. Switch maintain the entry in the MAC address table. What is the aging time? 300 seconds. And PC also maintain the which table, guys? ARP table. And in ARP table, the entry is for the 4 hours. Okay. This is the information I have, so I am sharing with you. Clear?
Yes. Sir.
The entry present in the PC ARP table, that entry will be for by default 4 hours. Okay. In Windows device, on Linux or on Mac,
Mac.
you guys can check on the Google, but on Windows, that is 4 hours. Clear?
Yes.
Yes.
Okay, guys, I already written all the points here. If you guys need to read, you guys can read it. Clear? Now, device and their ARP table. I told you these things. PC also maintain the which table, guys? ARP table. Okay. What is the command? ARP-A. When you run this command, this is the result. In this result, what you are getting? IP address with MAC address. Yes, na? And what is the TTL value? 4 hours. How much? 4 hours. Are you clear, everyone? Are you tell me? Yes.
Yes.
Yes, sir.
Switch maintain the MAC address table, not ARP table. And it helps the forwarding the data frame within the network. Okay, now switch do not maintain the ARP table like this. Okay, and router maintain the ARP table. Okay, and in a ARP table, router also maintain the IP address to MAC address. Router also maintain or map IP address to MAC address. See, now this is the ARP table. This is the command. So ARP command, when you run on the router, you guys will get this type of entry. See, now IP address and MAC address. Are you understand, everyone? Yes or no? Clear?
Yes. Got it.
Yes, sir.
I mentioned one diagram here. If you guys, okay, before I tell anything, I am just zooming it. I hope this is visible to all of you.
Yes.
Okay. I'm giving you just 2 minutes. Everyone, please see this diagram and try to learn something and try to understand something. First, try to understand at your end, then I will tell you. I hope you guys understand something.
It looks like the same thing you just explained.
Everything is same, guys. Anyone who do not understand, then I will tell you, otherwise I will skip it.
It's clear.
Skip. Okay. See now, IP address is this one. Subnet mask is this one. MAC address of this one. Okay. When you write the command ping, let's suppose this one. Okay. So this generate the ARP request, and I'm looking for the what is the MAC address of this IP address. So source MAC address is in ARP packet source MAC address is this one, and destination MAC address is broadcast at layer number 2. Yes or no? Packet will reach on switch. This is the broadcast packet, so switch will broadcast it. Packet will reach on here. This generate the ARP reply, right? And in ARP reply, this is sending the source MAC address. Source MAC address is this one, and destination MAC address is this one, because this PC now already know now what is the MAC address of this one, because this PC already received the ARP request. And when this PC received the ARP request, immediately make the entry in which table? ARP table. Tell me 172.1 for this IP address. What is the MAC address I am getting? 33333. Fine, getting my point. So when this device send the ARP, this is the broadcast. And when this device is sending, that is the unicast, because this device know the source MAC and destination MAC. And but this device don't know what is the destination MAC. Clear, everyone? Tell me.
Yes.
Yes, clear.
Yes, sir.
Now come on the ICMP. ICMP stands for Internet Control Message Protocol. Internet Control Message Protocol. Clear, everyone? Are tell me. Understand? One more thing. ICMP works at which layer? Layer number
3.
What is the use of ICMP? The use of ICMP to check the connectivity between
Reachability.
sender and receiver. To check the connectivity. Are you getting my point? If you are writing na ping 10.0.0.2, it means what you are doing. Ping is what? Ping is just like a utility. Ping is just utility. And ping works at ping use which protocol? ICMP. Ping is nothing. Ping is just like a utility. Understand, everyone? If anyone asks you what is ping, don't tell ping is the protocol. No, ping is not a protocol. Ping is just a utility that use ICMP protocol. Clear, everyone? I hope you guys
Yes.
have not confused now, right? It's clear? Okay. ICMP operates at which layer, guys? Layer number 3. Clear na? Are tell me. Okay. ICMP messages are encapsulated within the IP packet and are used to report error. This one I told you, this is the use of ICMP packet. Clear na? This is the ICMP header consists of, see, this is the ICMP header, guys. In ICMP header, what are the things you are getting? Type field, code, checksum. Type, code, and checksum. This is the thing which is present in the ICMP header. Are you clear, everyone? Yes or no?
Yes.
The
Yes.
ping. I don't know what is the full form of ping. If you guys want, you guys can remember it. What is packet internet grouper? Oh. Utility is the commonly used to test the network connectivity, right? Na? This is the use of ping. What is the use of ping? To check the connectivity between source and destination. Are you understand? Yes or no?
Yes,
Yes,
sir.
na? And ping use which protocol? ICMP protocol. See na, I told you about the ARP. ARP is also a protocol. Yes or no? Yes. And ARP use two type of messages. What? Request and reply.
Reply.
Case of ICMP. ICMP also use request and reply.
Reply.
Okay, request is called ICMP echo request and reply is called ICMP echo reply. Are you clear, everyone? Yes or no? Yes, na? ICMP echo reply. Clear? So same kind of thing like ARP. Clear? Understand?
Yes.
ICMP is the layer 3 protocol. And this is the header, guys. If you want, what are the thing in the header? I already mentioned here in this table. You guys can read it. Echo request. So please remember this one also, guys. Echo request. The type field is 8. So if in type field you are getting 8, it means this is the echo request. Same na in a ARP, there is the opcode value. Yes or no? If opcode is 1, it means this is the ARP request. And if opcode is 2, it means this is the ARP reply. Similarly, in case of ICMP, in ICMP, there is a type field. In type field, if you are getting 8, it means this is the request. And in type field, if you are getting 0, it means this is the reply. And in type field, if you are getting 3, it means host is unreachable. So these are the meaning of type field. Clear, everyone? Tell me yes or no.
Yes.
Tell me. Clear na?
Yes.
There are, apart from the type, there are one more value, that is the code. See na? What is code? What do you mean by code? Code field provide the additional information about network and whatever you are doing. Getting my point? So see now, if you are getting the code value 0, it means your network is unreachable. If code value is 1, it means one host is unreachable. So these are the meaning of code value. Getting my point? But what you will do? Next one is, guys, checksum. I hope you guys already aware about the checksum. What is the use of checksum, guys? To find out the error in header.
Error detection.
Right na? So checksum field is used to find out the error inside the header. So there are 3 things in the ICMP header. Type, I already told you, type. By the help of type field, you guys can identify this is the ICMP request or reply. Fine. Code means code tells us about the more tells more detail about the ICMP packet. Okay. And checksum tells us about the what error in the header. Are you clear, everyone? Yes or no? Tell me.
Yes, got it.
Okay. Now packet. Okay. Before start the packet flow, what I can do, I can show you the same packet flow. Here, I think it will help you more. I hope this is visible to all of you. Yes, na? This is the link local address. Link local address means this is the MAC address of this PC. Okay, everyone. So what I am doing, I am writing the MAC address here for our reference. Are you clear?
Yes.
So we are configuring the IP address 10.0.0.1. By default is this one. Okay, now so in this case, we do not need to configure the default gateway. You know, na everyone? Because every device is the
Yes.
same network, right? Na? So we do not need to configure the default gateway. Where we configure the default gateway? When we have a router, right? Na everyone? When we have a
Yes.
router. So in this case, we need to configure the default gateway because we need to forward your packet from one network to another. Clear? On PC number 1, I configure guys 10.1. Clear na everyone? Yes or no?
Yes.
So I configure here 10.1. On PC number 2, configuring 10.2. I hope you guys are aware how to configure the IP address.
Yes.
PC number 3, 10.3, and then PC number 4. Clear? Everyone.
Yes.
I told you ARPA. See now, no ARP entries is there. It means this PC right now do not make a entry in the ARP table. Yes or no? Everyone. Understand now? Okay. Now enable the interface range itna no shutdown. Okay. We want ARP and ICMP. We do not want these type of packet. Switch take how much time? 30 seconds. Okay. This is the also very important point, and we will discuss these things when I will teach you the STP. But right now, just understand switch will take how much time? 30 seconds. By
30
default, it
seconds.
takes to come in forwarding this in forwarding state.
Sir, there is also other ARP, reverse ARP.
There is also reverse ARP.
Reverse ARP, yeah.
That is called proxy ARP. Okay.
Okay.
Oh, why this generate the ARP? No problem. Come on here. Guys, let's suppose we are on PC number 1. I hope it's visible to all of you. Okay, now I want to ping, let's suppose PC number 4. So what is the IP address? Ping 10.0.0.4. Are you clear, everyone? Yes or no? Tell me.
Yes.
Clear now? Okay. Now see, on this device, please ignore there are 3 packets, but yes, only there will be a 2 packet. Okay, na? So see, what is this? When I press the move the cursor here, what is this? ICMP packet. They understand, everyone? Yes or no? What is this?
Yes.
ICMP.
ICMP packet.
SMP.
When you write the ping command, immediately your PC will generate the which packet, guys? ICMP packet.
ICMP packet.
Okay. So see, when I open this ICMP packet, see. ICMP packet. I hope this is visible to all of you. Yes, na? What is the source IP address? 10.1.
10.1, 10.4.
Right. And what is the type field?
Type
8
8
means this is the request. Array 8 means this is the request.
request.
I told you that. Okay. See here. When I am opening this ICMP packet, see, this is the header of ICMP. What is the type field? 0x08. It means this is the request.
Request.
Okay. This is the checksum, checksum. This is nothing. This is nothing. Okay. It means this is the ICMP header. Are you clear, everyone? Yes or no? This is the
Yes.
ICMP header. And I told you ICMP header. If you guys remember, I already written that point here. ICMP header is encapsulated with the IP packet. Yes or no? Everyone.
Yes.
ICMP packet is encapsulated with the
IP
IP
packet.
packet. So see now, that's the reason this is the ICMP packet, and here you guys are getting what? This is called IP header. This is called IP header. I told you, na, ICMP works at which layer? Layer number 3.
Layer 3.
So if it works at layer number 3, it means it must be encapsulated with the IP header.
IP header.
Yes or no? Everyone. Yes, na?
Yes.
So that's the reason ICMP packet have IP header also. So see, in IP header, everyone see very carefully. What is the version? 4. It means this is the IPv4, na, everyone? Yes or no?
Yes.
TTL is 128. If you guys
128.
remember, by default TTL is 255. I've told you, na. If you guys remember, but here 128. Why? Because this is the Windows device.
Windows
For
device.
For Windows TTL is 128, and for Cisco that is 255. Okay, and there's nothing. Source IP is 10.1,
1.
and destination is
10.4.
4. Are you getting my point, everyone? Yes or no? Yes,
Yes.
na?
Yes.
Okay. So this is the ICMP header, and again this is the IP header. Okay, everyone, and both are at layer number 3. Now layer number 3, hand over this to which one? Layer number 2. Yes or no? This is the flow, na, everyone? Are tell me?
Yes.
Yes.
Are understand like this? Let's suppose here you write ping. So it generates first of all what? ICMP header. Yes or no? Yes, at layer number 3. Ping also works at layer number 3. This is the ICMP header. It hand over to layer number 3. At layer number 3, what is the header, guys? IP header.
IP header.
Layer number 3, what is the header? IP header. Okay, so layer number 3 receive ICMP header, as well as what layer number 3 will do? Layer number 3 add IP header here. In an IP header, what is the content? Source IP will be 10.1 and destination IP address will be 10.4. Yes or no? Everyone tell me. Are you clear?
Yes. Yes.
In ICMP header, request type field is 8. Why? Because this is the request. Are you clear, everyone? Yes or no, everyone? Clear?
Yes.
Now,
Got it.
L3 will, layer number 3 will hand over this packet to layer number 2. And at layer number 3, data is known as packet. You guys know, na? I told you. Right? So layer number 2 receive this packet. What layer number 2 will do? In layer number 2, there is a which header? Ethernet header. Yes or no? Yes, na?
Yes.
Ethernet header, what layer number 2 will do? Layer number 2 add
Source
source
MAC.
MAC and destination MAC. What is the source MAC address? Source MAC address is this one, 2B70. This PC don't know what is the destination MAC address. Yes or no? Everyone tell me.
Yes.
Yes.
When I open this one, see, I'm not able to run this command here. But yes, there is no, in ARP entries, you guys will not get any MAC address there. Getting my point? So that's the reason destination MAC is not there. So it means, just tell me one thing. This packet is completely encapsulated or not encapsulated? Not. ICMP packet is not completely encapsulated. Yes or no? Why? Because at layer number 2, destination MAC address is missing.
Missing.
Getting my point, everyone? Even but in packet tracer, you guys will not get here. See, na, you guys are not getting, na, here you guys are getting what? ICMP header and IP header. Ethernet header are missing. Yes or no? Yes, na? At layer number
Yes.
2, Ethernet header are missing. Why? Because Ethernet header is not completely encapsulated. So that's the reason it is missing here. Are you getting my point, everyone? Yes or no? Yes? See, now,
Yes.
when I open this one, even you guys will get there. Maybe see, when I click on the layer number 2, what I am getting? The next hop IP address is unicast. The ARP process look it up the ARP table. Yes or no? The next hop IP address is not in the ARP table. The ARP process tried to send the ARP request for the IP address and buffer this packet. Getting my point? I hope you guys understand now. At layer number 2, when I click here at layer number 2, what I am getting? This device check the ARP table. And in ARP table, what is the entry? IP address map with the MAC address. Right, na? So destination IP address is, I write 10.0.0.4. And this is the unicast, na? And this device are not getting this IP address here. So if this device is not getting this IP address, then how get the MAC address? It means both are missing here. Are you getting my point? So that's the reason this device will generate which packet? ARP packet. Are you clear, everyone? Anyone who do not understand? Are you tell me? Clear?
Yes, sir.
Yes.
Okay. See, when I click here, what is this? This is the ARP packet. See now? I hope this is visible to all of you. What is this? This is the ARP packet. Understand? In ARP packet, what is the source MAC address? 2B70, and 2B70 is the MAC address of this one. Yes or no? Everyone, tell me. Yes?
Yes.
Tell me.
Yes.
Source IP address is 10.1.
One.
It means this is the MAC IP address of this device. What is the target MAC address?
0, 0.
0. I told you, na?
Zeros.
Why 0? Because
Unknown.
PC number 1, this is unknown.
Unknown.
That's the reason it is 000. Target IP address is
10, 10, 1.
10.10.1. Why?
Source IP, target IP.
Okay.
This is
there are-
Gracious ARP. Gracious
This is the
ARP. Is it?
This is the gracious ARP. This is the gracious ARP. Okay, no problem. Let me. See, this is the actual ARP packet. See now, what is the source IP? 10.1. Target IP is 10.4.
10.4.
Target is 0,
0,
0, 0. Right? Source MAC is this one.
2B70.
Yes. And this generate at layer 2.5, it hand over to layer number 2. That is called
Two.
Ethernet, right?
Ethernet.
In Ethernet, what is the destination MAC address? FFF.
FFF.
Yes, na? So it means this packet will reach on switch. What switch will do? Switch will broadcast it. Switch will broadcast it. Yes or no? Everyone, tell me. Tell me. Yes or no? Yes, na? So see,
Yes,
this
sir.
is the inbound. Inbound means switch receive this packet, and outbound means switch will forward this packet. Okay, now so here you guys can check. Switch receive this one. It means this is the inbound, and in outbound you can check or you can compare. Is there any modification switch is doing? Switch is performing any types of modification here. Here, do you guys get any types of modification? No. Switch is not doing any types of modification here. Are you getting my point, everyone? Yes or no? Yes, na? So
Yes.
switch, see the switch broadcast it. Switch just broadcast it. Are you getting my point? Now, when switch broadcast it, it means this ARP request receive at here, here, and here. Yes or no? It means all the three devices receive the ARP request. Yes or no? Everyone. Tell me.
Yes.
Yes,
Yes,
na?
sir.
In ARP request, what is the source MAC address? Are 2B70. This is the source
270.
MAC address. Na? Destination is this
0,
one.
0.
Okay. Are understand? Yes or no? Yes, na? What
Yes,
is the IP address? Target IP address 10.4. What is the target IP address?
10.4.
10.4. Every device open the packet. Every device check. What is the target IP address? 10.4.
10.4.
Then this device will get. My IP address is 10.2, not 10.4. So this
10.4.
device drop it, this device drop it, and this device accept it.
Accept.
Getting my point? Everyone understand? Tell
Yes.
me. Okay. So
Yes.
finally, PC
Yes.
number, this PC number 4 accept this packet. Are you clear? Now I
Yes.
am opening this packet. See, this is the inbound. It means this is the ARP packet this PC receive. Are you getting my point? This is
Yes.
the ARP packet this device receive. Now see, now if you see now, what is the destination address? FFF. It means this is the packet this device receive. Right? Now come on in outbound. In outbound, you guys will get modification. Yes or no? See now,
Yes.
what is the destination address now?
2B70.
Destination is 2B70. It means this one, this device MAC address.
Yeah.
Yes or no? Yes. And source MAC address is this one. Yes or no?
0899. Yes.
Source MAC address is this one. Source IP address is this one. Target is this one. And target IP is this one. It means this is the unicast.
ARP reply.
And this is called, guys, ARP reply.
Reply.
This is the ARP reply. Are you clear, everyone? Yes or no? Understand?
Yes.
Yes. Got.
See, this packet will reach on switch. Now tell me, switch receive this packet. This packet is unicast or unicast or broadcast?
Unicast.
Unicast.
In this case, switch is not going to broadcast it. Switch only forward this packet towards PC number 1. Yes or no? Are tell me.
Yes.
Yes, na? Because switch already maintain the MAC address table now. So MAC address table. See na? Switch already maintain the MAC address table because switch already know na at 2B70, which means this is the MAC address on which interface? One.
FGOs.
Yes. And at 0/3 at this one, what is the MAC address? 0A99, this one. Yes or no? Everyone tell me.
Yes. Got it.
Yes.
Yes. Switch already maintain the MAC address table. And now switch will take the forwarding decision on the basis of this MAC address table. Are you clear, everyone, till now? See, switch do not broadcast it. Switch just forward this packet towards PC number 1. Are you getting my point, everyone? Tell me yes or no. Yes.
Yes.
Now what switch PC number 1 will do? PC number 1 receive this ARP reply packet, and in this ARP reply packet, this open the what source IP address and source MAC address and make the entry in which table? ARP table.
type.
Same PC number 4 did. When you check the PC number 4, so what is the command, guys? ARP.
Minus there.
See na? This PC already make the entry now. What is the source MAC address? Z10.1.
1.1.
And for 10.1, what is the MAC address? This one.
2B70.
This is happening then dynamically. I hope you guys understand. Clear na, everyone?
Yes, got it.
Okay. Now the thing is, that time when you write the here ping command, at that time PC number 1 generate the ICMP packet, if you guys remember. Right na? And
Yes.
at that time, that ICMP packet was not completely encapsulated because destination MAC address was missing. Yes or no? Right na?
Yes.
Okay. But now this PC know now what is the destination MAC address because of the ARP reply. Yes na?
Yes.
Tell me. Now see, this
Yes.
is the ICMP packet. Okay, I am opening this ICMP packet. See, this is the ICMP header. Yes or no? Yes? Tell me.
Yes.
Yes na? This is the
Yes.
ARP header. Yes or no? Tell me. And now
Yes.
see now, this is the Ethernet header. I hope you guys are able to now see the Ethernet header. But at that time when I show you that time, this was missing. Right now, everyone?
Yes.
Why? Because this header was not completely encapsulated. So that is the reason this header was missing.
If we see now, so
No,
it will be
that is not
completely
the new packet.
encapsulated.
When you write the ping command, na, this packet,
Yes.
ICMP packet will hold.
It's the,
Okay.
um,
Yes, this is the first packet. So
now
that's
if
the
we
reason.
try to send second packet,
That's the reason. If you guys observe it, when you let's suppose when you are pinging any device first time, you guys are seeing na, maybe I don't know you guys are observe or not. By default, device is sending the 4 packet, and sometimes you get 80% successful, 70% successful, 60% successful. Getting yes or no? Yes. Sometimes you guys are getting like this. It means what? It means some packet is drop. Some packet is just drop. Why? Because here ARP process is happening. What is ARP process is happening? For so due to ARP process happening, it takes some time. So that's the reason some packet was drop, because there are some time criteria for the ICMP packet. If packet will receive the reply between that time frame, then it will be successful. Otherwise, your packet will drop. So that's the reason you are getting these type of result. I hope you guys understand. So please don't think this is the new packet. No, this is the old packet. That packet was old. Clear, everyone?
Okay.
So that time, guys, Ethernet header was missing. Why? Because the header was not encapsulated. But see, now what is the source MAC address? This one, and destination MAC address. This one. Are you getting my point, everyone? Yes or no? Yes. So
Yes.
at layer number 3 in IP header, source IP is this one, destination IP is this one. Clear? It means now this ICMP packet is completely encapsulated. Yes or no? And this ICMP packet is unicast or broadcast? Unicast,
Unicast.
right? Oof. Now what will happen? This switch forward, switch receive it. What switch will do? What switch will
Forward.
do?
Forwarding the
Switch check what is the source MAC address. What is the source MAC address here? Source MAC address is 2B70. Yes or no? Everyone tell me. Yes? But
Yes.
when you open the MAC address table, na, 2B70 is already present here. Right? So in
Yes.
this case, what switch will do? Switch do not learn the MAC address. Switch just reset the aging timer.
Aging time.
Switch just reset the aging timer.
No.
Getting my point, everyone? Yes or no? Yes?
Yes.
Now switch
Yes.
will check what is the destination MAC address. 0A99. 0A99. So then switch will check 0899 is present by which interface? Fast Ethernet 0 by 3. So it means this switch already know through which interface I need to forward this packet. Yes or no? Yes. So now this switch will
Yes.
forward this packet by 0 by 3. Getting my point, everyone? Yes or no? Are tell me. See
Yes.
now when I
Yes, sir.
check this, is there any modification? No, you guys will not get any types of modification here. Okay. See now switch forward this packet. Packet will reach on where? PC number 4. Yes or no? This is the
Yes.
packet. Right? Everyone. Now what PC number 4 will do? This is the ICMP request packet. Yes or no? PC number 4. Now PC number 4 will generate the ICMP reply. What is the change? What is the change? Only some changes are there. What is the destination at MAC address? 2B70. What is the source? A99. Right now, everyone. Source IP address is this one. Destination IP address is this one. Are tell me, everyone. Understand? Yes or no? Yes, na. So this is
Yes.
called
Yes.
ICMP reply. See, this ICMP packet will come on PC number switch number 1. What switch will do? Again, switch will check the MAC address table. Yes or no? And according to
Yes.
the
And
MAC
reset
address,
agent.
this packet to PC number 1.
1
It means now communication is successful.
successfully.
Anyone who do not understand the packet flow in the same subnet? Anyone? Are clear, everyone? Yes or no? Tell me.
It's clear.
Yes, got it.
See na. This PC generate how many packet? 1, 2, 3, and 4. 4 packets send na, everyone? Yes or no? 4
Yes.
packets send, receive reply also 4, lost 0%. It means success rate is 100%. And this PC also maintains that ARP table. Na? See, for 10.4, what is the MAC address? This one. Hey, clear, everyone? Tell me.
Yes.
Yes, sir.
Anyone who do not understand? Are you understand, everyone? Yes or no? Yes?
Yes.
Yes, sir.
Yes, sir.
Switch. So MAC address table. When I am running the so MAC address table, these 2 entries are there. Right now, everyone? One for 2B70 and second one is 0999. Are 0899. Yes or no, everyone? Tell me yes or no. Yes? I am running one
Yes.
command.
Yes, sir.
Clear.
MAC address table.
Clear. MAC address table. I press the question mark and dynamic. Okay, I am running one more times. Now see, is there any entry now?
No.
No.
Entry? Are tell me yes or no? Is there any entry?
No.
No, na? Everyone. Guys, this is very important. No entry. It means try to understand one thing. On switch MAC address table, there is no entry. But when I check this PC and this PC MAC address table, sorry, ARP table, guys, then you guys will get entry. Yes or no? Because in ARP table,
Yes.
entry is present for the 4 hour. Yes or no? So in
Yes.
ARP table, you guys will get the entry. Yes or no? Tell me.
Yes.
Yes.
Okay. So see na, come here. Come here. Entry is there. Yes or no? Tell me.
Yes.
Yes.
Now think here very carefully. I write here ping 10.4. What will happen? First of all, PC number 1 will generate the which packet, guys? ICMP packet. Yes or no? In ICMP packet, what is the content? Source IP. Source IP will be, guys, 10.1. Destination IP will be, guys,
10.4.
Fine. Source MAC will be, guys,
2v7.
2v7. And destination MAC will be, guys,
899.
confirm, 899.
Yes.
Yes, exactly. Why? Because this PC check what is the destination IP address 10.4. This PC check the ARP table, and in ARP table this PC find 10.4 and MAC address of 10.4 is this one. So ARP table MAC address table will be A99. Are you clear, everyone? Yes or no? Yes.
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 So in
Yes,
this
sir.
case, this PC know every information here. So it means this PC do not generate the ARP packet now, because ARP packets PC will generate the ARP packet only when there is a missing, na, when destination MAC address missing. Yes, na. But this
Yes.
PC already know the destination MAC address, so there is no need of ARP packet. Yes or no? Yes.
Yes.
What will happen? And this is called unicast packet or broadcast packet, guys. Unicast packet.
Unicast.
Right?
Unicast.
Because every address is present here. This packet will reach on switch. What switch will do? Switch will first of all check the source MAC address. What is the source MAC address? 2370. In MAC address table, switch learned on 0 by 1 MAC address is 2370. Now switch will check what is the destination MAC address. Destination MAC address is A99. Now this switch will check its MAC address table. But I already write the command, na, clear MAC address table. Yes or no?
Yes.
Yes.
So now A99 is not present in its MAC address table.
MAC address
So in
table.
this case, what switch will do? Switch will
Broadcast.
Broadcast.
I hope you guys understand the concept, right? But why
Yes.
I am telling you, packet is unicast. Switch is receiving the packet unicast. But what switch is doing? Switch is broadcasting.
Broadcast.
Interviewer will ask you these type of scenario based question. Maybe you guys will confuse. Question interviewer can ask you, tell me, is it possible in a network if any device like switch receive the unicast packet and it will broadcast? You guys will simply tell, no, it is not possible. Unicast means unicast, broadcast means broadcast. No. This is the scenario where switch is getting the unicast, but switch will broadcast it. Are you getting my point? Yes or no? Tell me.
Yes, sir.
Yes. Got it.
Got it now, everyone? See, I already
Yes, sir.
let me check. Yes, there is no entry in the ARP table. Now, come here. I write here ping 10.4. Okay. So, what it will do? It will generate the ICMP packet. Yes or no? Yes? Are you tell me? In ICMP packet, see, everything is there because Ethernet header is also encapsulated. It means everything is there. Right now, destination MAC address is there, source MAC address is there, source IP address, source destination IP address, complete information is there. It means this is the unicast packet. Yes or no? Are you tell me? Yes?
Yes.
Okay. Packet will reach on switch. What
Switch.
switch?
Broadcast.
This is the thing what I want to show you. Clear, everyone?
Yes. Got it.
Yes.
Okay, now. So this is the packet flow in the same subnet, guys. In tomorrow class, we will discuss the packet flow in the different subnet. Okay, everyone. I hope you guys understand and enjoy the class.